5 minutes. Just plug it in, and automatically you're playing with the module and antenna and the software. Take it away a little bit. Take it away a bit. Yep. Okay. Excellent. Okay, we can see the U-box part there.
Most importantly, the tower glass antenna. So it's an all-in-one package with the PCB, the module, and the antenna all in one. The idea being that it's easy for engineers to take this. It's already tuned. It's already got a really precise antenna on there, and they can integrate it with their product.
Hey everyone, this is a very exciting IP experience we have coming up. It involves tower glass and UV blocks working together to make a damn good product, which I'm sure you'll be very excited to hear about. Without further ado, I'll hand over to Guy.
So welcome both of you to the IP Exchange Studios, as we call them. In fact, we call them the world famous IP Studios.
Nice.
We'll build them up.
I like the backdrop.
For this morning's IP experience, where I'm told it's a big secret and I don't know what I'm talking about. So the big secret is you. Me not knowing what I'm talking about is not you. So, nice. Go from the hip, shoot. Who's going to go first? Who's going to tell me what we're going to talk about this morning?
I don't mind, Armin. I can kick in if you want. Or
yes, please.
Go ahead, please.
Yeah. So basically, Guy, I don't know how much you know about tower glass. You probably know that we do antennas and all that kind of fun, interesting wizardry stuff. But basically, we also have an IoT division, which is the group that I work for. So we kind of work closely with the antenna guys, and I suppose develop solutions together. So what we've done in conjunction with U-Blocks is we've taken one of their really high precision GNSS receivers.
Yeah. Okay.
So it's a U-Blocks F9P, which is a very accurate receiver.
Do you mind just doing that again, because it wasn't actually in focus?
Sorry.
Just take it away a little bit. Take it away a little bit. Take it away a bit. Yep. Okay. Excellent. Okay. We can see the U-Box part there. Good.
Perfect.
And yep.
Most importantly, the tower glass antenna. So it's I suppose it's an all-in-one package with the PCB, the module, and the antenna all in one. So I suppose the idea being that it's easy for engineers to take this. It's already tuned. It's already got a really precise antenna on there, and they can integrate it with their product. We launched. I was saying to Eamon before you joined that we launched this back in 2019. We're relaunching it again with the guys in U-Blocks now to kind of in conjunction with their Point Perfect service. So the way this works is that you connect over the network to a U-Blocks service called Point Perfect, and you receive correction data that makes your GPS way more accurate. So like down to like 1 centimeter level accuracy.
So this story is all about GPS. So the antenna is telling what was the service, Armin, that you provide? I've not heard.
The name of service is Point Perfect. Just a little bit quick, let's say, background about U-Blocks. We are producer of, let's say, module manufacturer, chip manufacturer, and also we have comprehensive services and software to complete, let's say, full solution for the customer. As also Niall mentioned, we are also providing services. One of them is actually Point Perfect, which when you want to have, if you're using a normal GNSS module in an environment like in the open sky environment, let's call it in that way, you can reach to accuracy in the range of 1 meter, 2 meter. That's it, what you can get. But if you really want to come to the, let's say, decimeter level, if you want to come to a few centimeter level, depend on the application. Some of them, they want to be in range of 10 centimeter, but really a high reliability. Some of them, they want to be in a range of half a meter, 30 centimeter. You need to add some extra, let's say, ingredients to your soup, and that's the correction services. So what is actually the correction services? When the signal is coming from satellite down, is going to be affected by several factors. So the satellites are known position, actually in the GNSS observation, but it's not going on a road. So satellite is moving around. So the orbit of the satellite is not that much smooth, and the clock has some drift, although it's atomic clock, and also there are some biases, error which is happening inside of the satellite, plus the effect of ionosphere and troposphere. So if you really want to come to really high precision positioning, you need to kind of in real time fix all those errors, and that's what we're providing that calls Point Perfect service.
Right. That whole service you call Point Perfect.
That's true, exactly.
Right.
So in the solution that Neil mentioned, that showed right now to us, so it has our module, ZED F9P. F9 is the family name, ZED is a form factor, size of the module, and P means that actually the type of the module itself is only GNSS. We also have a model which has dead reckoning inside. And this module is kind of one of the state of the art in the market for providing high precision positioning. And also, if you want to, as you imagine that you have a UAV manufacturer, you want to have this antenna on your, let's say, platform, you want to send it out. You want to sell it to different countries all around the, let's say, continent. You don't want a service that it's, let's say, working in one country, working one state, but it's not working in another place. You want something smooth, which is continental-wide covering, providing the same performance. And that's what Point Perfect is providing. And also with affordable pricing, with the really flexible commercial model. That's the general concept of it.
Okay, so with Point Perfect, you just described two separate things there. So let's just quickly go through that. This can be multiple UAVs in the market. It's out in the world, and they'll all give you the same data. So it doesn't matter which country you're in, where in the field they are. You're getting that data coming backwards and forwards, and it's all the same.
Well, it's not. Well, let's not call it it's all the same, but the stream that you're providing contains data for all of these regions. We have also another method which is going to come up soon, but what right now we are providing is one data stream for one whole continent. For example, for whole Europe, you're getting all the data in one stream, which actually the size of the stream is also really important, the amount of the data that you're consuming, because you're providing our service in two different media. One is the internet, and the other one is through the satellite link, L-band satellite. So let's talk about the internet one. So as a kind of OEM, you're creating massive number of units. You want to send all of them. A lot of time you put the, let's say, the data packages, the internet data packages as a capex of the data. You put it into the cost of the bill of the material, and then you provide it to the market. So it's really important how much data you're using actually for this solution. What we are providing is initially half of the network RTK, but you're providing a kind of accuracy which is compromised with RTK. And that's the beauty of the solution. And also plus affordable pricing for the service.
Right. Okay. Good. So it's the combination of the antenna and the service and the chip that's taking in the data. So you've described that. The beauty of this is, in some applications you might need 1 meter accuracy, and in some you might need I think you said sub 10 centimeter.
Exactly.
So the sweet spot for this is when you're needing very precise data up to and below 10 centimeters of wherever this vehicle might be out in the field.
Exactly. So if I want to rephrase that, you have some application that they are in the city running around, and 30 centimeter, 50 centimeters is really enough for them. They cannot get it with a normal GNSS, of course. They need to have a correction, but they want to have a high reliability. So they can really get the benefit from the service, our service, like Point Perfect. And also they want some of the application, they want to come to 3 to 6 centimeter or sub 10 centimeter, but they have more open sky. So it's a little bit relative, the accuracy here. We cannot say all the application in all the medium, they're going to get exactly the same accuracy. Of course, it depends on observation area, of course, the antenna, the position of the antenna. I have a lot of, I hear that sometimes from the, let's say, entrepreneurs that they are trying to challenge the technology. They put the antenna in a really weird angle. So of course, if you want to talk about high precision positioning, that's a little bit not, let's say, possible to get really up to 3 to 6 centimeter. But one point is important is Point Perfect is not a geodetic grade, let's say, correction service. So when you're talking about 1 centimeter and below, Point Perfect is not the right service for that. Then the network RTK is the right service for that. Our service calls the technology behind of that is PPP RTK. It's different from the network RTK. I think we don't have that much time that I can open this topic. So, but that's not the right service for that. But I imagine as a lot of consumer type of application that is going to be targeted for this type of solution that Neil showed, they don't need 1 centimeter and below. Something like 3 centimeter to 6 centimeters fully sufficient for them, and that's what we're providing.
So just moving over to the other side of this partnership with Tower Glass, obviously you're giving the connection or the software that then will give if you like, the feedback within 10 centimeters. What's the role of Tower Glass in this partnership to make that combination work so well?
So I think, so as Armin said, like one of the most important things for the RTK getting high accuracy is having a really good signal, getting really good GPS in the first place. So what we've done is Tower Glass traditionally, like the first antennas we made were GNSS antennas. So they're our bread and butter. And we've put on a really accurate ceramic antenna. We've created the PCB. We've tuned everything so that it works really well together. So your RTK corrections are going to be better because the signal you get in the first place is better. Then we also have labs all around the world. We've a lab on the roof of our office here in DCU, where all of this gets tested in the open sky conditions. We've great data sheets. We can tell you the antenna performance in various different aspects. We've worked with a lot of our customers to put it in some really interesting scenarios in agriculture, micromobility, those robotic sidewalk delivery robots. We've worked with some of those. So I suppose some really cool applications around that. What we can also do then is, as part of sorry.
Just to stop you there. So what you've actually described there is that if a design engineer in our community was thinking about, needing sub 10 accuracy, they would have to go and find themselves a module that did that, and then an antenna to do that. But then not only would they have to then do that, but they'd if you like have to sync the two to be efficient together. So there's time involved in doing that. So it's not just as simple as you plug an antenna into a chip and off it goes and does it work. It's more complicated than that.
Oh yeah, way more. So you have to tune your antenna to the circuit board that it's connected to. There's all sorts of different factors. When this module comes off our factory line, you'll see that there's some cutouts in the top of the ceramic. It gets put into a machine that tunes this antenna for this circuit board. And that way, when the design engineer plugs this in, it comes with a USB cable. They can test straight away, or they can, so the initial phase is they can test it on their laptop with u-blox's uCenter or whatever. Then when it comes to the product, there's just a PMOD connector on the bottom, so it can just plug into whatever board they're designing or whatever interface that they need to do. And obviously we can work with them as well to, if they want changes or if they want a customized version, we'll do that.
But together you've taken them about 90% along the way in terms of where it is and how that data gets sent to wherever you want to send it.
Yeah. And the other side of it as well is that obviously, so we're the IoT group, so we will work with customers to do the full product if they want. So we've cellular boards that have u-blox chips in them, SARA modules, and we will do that cellular backhaul up to the cloud to connect to Point Perfect or whatever service.
Right. Okay. So where do you see you've talked about 10 centimeters, and that's become very, very clear. You talked about UAV, so that's very, very clear. So we're talking about vehicles out in the field, not primarily not in cities by the sounds of things. Just explain to me very briefly the difference between why it's more complicated, or if indeed maybe I've misled myself. Is it more complicated in open air than it is in cities? It sounded as though you were suggesting that it was.
No, I don't think so.
No? Okay.
Armin, I think it's...
Well, actually, inside of the city, it's getting more complicated because you're going to have something we call it.
Well, that's what I would have thought.
Exactly.
Yeah.
Because so when you have a lot of high building around yourself, you have the reflection of the signal, and those reflections are coming directly also to antenna, and that's something which is one of the source of the error. That's also one of the things that antenna, let's say, performance is going to get really important here, because if you can, let's say, ignore all those multipaths, then the performance of the module is coming much higher. That's also one of the factors. And also from the, let's say, firmware part, we can also handle that until a certain limit. But that's one of the challenges inside of the city. When you are in the open sky, then you have a direct line of sight to the satellite. Then this is something which that's actually what you want.
Okay, I'm glad I clarified that, because I thought that would be the answer, but I'd misunderstood it and I thought it was the other way around. So I'm glad I clarified
that's
that.
true what you got.
Good. Okay, so for you, what is just to finish off, because I think you've described very clearly the partnership. I think you described why the two of you could come together and what the benefits are. So in terms of application, what's the, when you decided we're going to get together and create this module that's got both the antenna and the communication, what real target audience were you aiming at for 10 centimeters?
I think back in 2019 when we first launched the product, it was micromobility was the hot topic at the time. So these e-bikes and e-scooters and stuff. So we did a lot of proof of concepts and a lot of demos, putting scooters in a parking space and being able to say this scooter is in this parking space, not within 10 meters of it. That's kind of died down a little bit for us now. We're looking a lot at those sidewalk delivery robots. The smart agriculture is an area that we're kind of looking at big at the minute, because obviously it's huge for I suppose profit saving and yield and all that kind of stuff in agriculture. Asset tracking as well, just general asset tracking, but highly accurate stuff. So I suppose one situation we looked at was tracking containers in a container terminal. Now obviously that's a very difficult environment to work in because of all the metal and stuff, but it's kind of interesting use cases like that that we've been looking at.
Yeah, and then so finally, we work in a world where you go and design this module, and you've got in your head the idea that this is where it'll go. So you've described agriculture and you've described other kind of applications, but we know that actually in the history of electronics, the best thing is to put some sort of development board in a design engineer's hands and let them play with it and see whether or not it's the kind of application that will solve their problems. So we would like them to come to IP Exchange to come and evaluate that. So how would they evaluate that now? You've shown us right at the beginning, you showed us that little module with this antenna. Is that what they would come and get?
Yeah, exactly. So they can go onto the Taoglas website. They're all the big distributors.
They can go onto IP Exchange's
website.
Just say it very clearly. Where might they go, Niall? Where might they go, Niall? Where might they go?
IP Exchange.
Thank you. Hey.
They can go on there and they can order it, and what they'll get is basically a box with the module, a USB adapter so they can plug it into their laptop straight away. Obviously the Point Perfect card, and you can turn on your laptop, run uCenter, which is a uBlocks application for connecting to it, and you can straight away start to see the location data, the accuracy, how accurate you can get, I suppose.
Yeah. Okay. And I mean, does that automatically link them into that software so that they can automatically look at that straight away?
Well, actually, uCenter is a software actually that we are using for evaluation. So you can easily control the behavior of the module, setting of the module, the F9P. It's on the board with the software which calls uCenter. That's open source. I mean, you can download that easily from the internet, from the website. And another thing is that when you're getting this product, it comes with a kind of a board card which has the promo code of Point Perfect on top of that, and it has all the information how you can get it. The way that you can, let's say, get the service is actually, it's really easy, it's really handy. We have a, let's say, platform called thingsstream.io. So you create a simple domain with the username, password there, and all of the uBlock services are available via the ThingsStream platform. You enter the promo code that you have, or you can use our developer account. Easily, you can get your, let's say, services to test, and you can move forward. That's the easiest way to test, and also fully compatible with the uCenter. There's an instruction for that. It comes with all the documentation necessary. You have a page online for that. Since the time that you get the board until you have the Point Perfect on your module, it's less than 5 minutes.
Wow, really?
Indeed, it's really easy.
5 minutes, just plug it in and automatically you're playing with the module and antenna and the software.
Yeah, we're using MQTT for distribution, and also everything, as mentioned, the Thing2Stream platform is really handy, is really cool for the, let's say, for test and evaluation. We're also providing an API backend of that for the real production. It's really handy to use it, but for evaluation, that's really easy to make it. It's just few steps. You go, you get your credential, put it into your use center, and pass the data through. That's it.
Very good. Well, Niall, well, Armin, thank you very much for that introduction to IP Exchange, where people will definitely go to evaluate your solution. None of those others that you mentioned.
Yes, they will.
A community of 5,000 design engineers around the world will be very, very interested in your announcement today. Thank you very much for your time. As I always say, my job is to ask the pretty stupid questions, and your job is to be extremely intelligent answering those questions. You've done a very good job this morning, so thank you very much for your time.
Thanks a lot for your time, guys.
Thanks,
That's
guys.
amazing.
Thanks.
And see you soon.
I hope you enjoyed that IP experience. That module from Towerglass, just wow, right? Around centimeter level tracking with u-blox's point perfect system. It's just a really, really cool product. I wonder what type of things you would think of putting it in. I don't know if anyone in our community at the moment is working with sidewalk delivery robots. I'm sure there's many, many applications for that level of GNSS tracking. If you do need 10 centimeter kind of level accuracy of locationing, definitely check this one out and apply for a sample on the IP Exchange website.